Welcome to our deep dive. Today, we're looking into your source material on decimals.
That's right.
Our goal is to really pull out the key ideas, the rules that make these numbers work.
Sort of a shortcut to understanding them, you could say.
Exactly. How they function, why they matter. Okay, let's get into it.
Absolutely. Your sources start right at the core,
hmm
a decimal fraction. It's really just a fraction, but a specific kind.
Specific how?
The denominator is always a power of 10. So 10 or 100 or 1,000 and so on.
Okay. So the decimal point, that little dot,
Yeah,
it's just a way to write those fractions without the bottom number.
precisely. It saves writing out 213 over 100. You just write 2.13. Much quicker.
And how we say them, like 21.45?
Yeah, saying the digits individually after the point.
That really emphasizes the place value, doesn't it? The tenths, hundredths, thousandths.
It does. It mirrors the units, tens, hundreds on the other side of the point. It's quite elegant.
It is. And something your source mentioned I found interesting was adding zeros at the end.
Oh, right. After the last decimal digit.
Yeah. Like 3.5 is the same as 3.50 or 3.500. It feels obvious, but it's useful, isn't it? Especially for lining things up.
That lining up idea is, well, crucial for addition and subtraction. That's the main rule there.
Just stack them so the decimal points are vertically aligned.
Exactly. Get that right, and then you just add or subtract like you normally would with whole numbers. Simple as that.
Okay, that makes sense. Keeps the place values straight. But multiplication is different. You don't line up the points first.
No, you don't. You treat them like whole numbers initially. Just multiply them out, ignoring the decimals for a moment.
Okay, then what?
Then you count. Count the total number of digits after the decimal point in both the numbers you originally multiplied.
A total number, okay.
And that total tells you how many decimal places your final answer needs. You count in from the right of your answer.
I see. It's a neat trick, really. Reflects the powers of 10 involved.
It is. And division. Especially dividing by a decimal. Your sources have a good method for that.
Right, because dividing by, say, 0.5 seems trickier than dividing by 5.
It does. So the trick is to make the divisor, the number you're dividing by, into a whole number.
How do you do that without changing the answer?
You shift the decimal point in both numbers, the divisor and the dividend, by the same number of places to the right.
So if you shift the divisor one place, you shift the dividend one place too.
Exactly, until the divisor is whole. Then you just perform the division, making sure the decimal point in the answer lines up with the new position in the dividend.
Clever. You're basically multiplying the top and bottom of the fraction by the same power of 10.
That's effectively what's happening, yes. It simplifies the process.
Right.
But the results aren't always simple whole numbers or neat decimals.
True. The sources talk about terminating decimals.
Yes, those are the ones where the division just ends, no remainder. Like 31.76 divided by 4 is exactly 7.94. It terminates.
But sometimes they don't end.
Right. Those are non-terminating. They just keep going.
Like, famously, 1 divided by 3.
Precisely. Or 2 divided by 3 giving 0.666, and so on. That brings us to recurring decimals.
Where a digit, or maybe a sequence of digits, repeats forever.
Yes. And we have notation for that, the dot or the bar over the repeating part, like 0.6 with a dot over the 6.
A concise way to show something infinite. It's quite neat.
It is. But because you can have these infinite decimals, or sometimes you just don't need that level of detail.
You need rounding.
Exactly. Rounding off is practical. Your sources mentioned the standard rule.
Look at the digit after the place you want to keep.
That's the one. If it's 5 or more, you round up the last digit you're keeping.
And if it's less than 5, you just leave that last digit as it is.
Correct. It's about managing precision appropriately.
So we've really gone from the basic definition, the notation, through adding, subtracting, multiplying, dividing, even these different types, terminating, recurring, and rounding, all from your sources.
It shows that decimals, while they seem simple on the surface, have this consistent set of rules.
Yeah, rules that make them really powerful tools for precision.
Absolutely. So thinking about this, what does it mean for you, the listener, when you're out there?
Looking at prices or measurements, maybe sports stats.
You're seeing these decimal rules constantly at play. Understanding them helps make sense of that numerical world.
It really does. Which leads to a final thought. Now that you maybe see the structure underneath decimals a bit more clearly, how might that change how you interpret the numbers you encounter every single day?